of Leetcode problem 2265, count nodes equal to average of subtree. Let's first analyze the problem. So we are giving a binary tree. Yeah, because we can see the tree node. So it is a left and right, it's binary tree. And we are also giving the root. We just want to calculate, let's say a subtree. Let's say we want to return the number of nodes where the value of the node is equal to the average of the value in its subtree. Let me just give you an example. So for example, this is root 4. The value of the root is 4, and the average of all the nodes. For this subtree, it means it includes the root. It includes the root node and the left tree and the right tree. It includes all of the nodes. So all those numbers, the sum of all those numbers divided by 6. So the value is 4. 24 divided by 6, it should be rounded down, not rounded up. Because according to the question, it is rounded down. So if it is 4, so let's check the root value. It is also 4. So it means this is one of the results. And similarly, we can also check all other nodes, 5, 6, 0, or 1. So in total, there are 5 nodes. If you understand the question, basically, you can try to solve the problem. So when I meet this question, first of all, I think this should be a tree traversal problem. But what kind of a traversal? So there are in-order traversal, pre-order traversal, and post-order traversal. Because I always want to get a node. For example, this is a root node. But before I get the root node, I need to know what is the left side and what is the sum of the right side, and how many nodes in the left side and how many nodes in the right side. So this means before I want to know the root node, I need to know the left tree and the right tree. This means it is a post-order traversal. Why? So for example, if I know from the left side there are 3 nodes, and I know the sum of the 3 nodes is 9, and I also know from the right side there are 2 nodes, and the sum of those 2 nodes is 11. So basically, I already know the answer for this node 4. So this is a post-order traversal way. But how can we solve this problem? So there are 1000 nodes maximum. So this means we can use the O(n) square solution. So for example, for this node 4, if we don't use the post-order traversal, we can use any kind of a traversal. Basically it's a traversal problem. We can use a traversal to get how many nodes in total, including this root node, and what is the sum of them. Basically I need an O(n) time. But when I come to node left side, this node 8, I also need the O(n) time. So in total, I need O(n) squared time. You can use any kind of traversal, and while you are using the traversal, basically you can get how many nodes and what is the sum of the node. But this is not the best way to solve the problem. What I mean is when I use post-order traversal, before I calculate this node 4, how many nodes and what is the total of all the subtree, I've already calculated every one of them. So this is basically O(n) time. So this is why this is a tree DP problem. So what it is called tree DP. This is while we are using the DFS for the tree, actually we are also using the DP idea. Because while we are calculating this one, all the others has already been calculated. While we are calculating this 8, and the 0 and 1 has already been calculated. So now let's try to use this DP tree method to solve the problem. First of all, let me define the function. As I said, it should be post-order traversal. You cannot use any other traversals for the O(n) solution. You can use like pre-order or in-order traversal for the O(n) square, but that is not possible for O(n) time complexity. You have to use post-order because you have to check the left and right and then for the root node. So inside the post-order traversal, I'm gonna prepare a node. Because I want to calculate how many solutions, basically I need to define a global variable. Let me define a self.result. From the beginning, it will be 0. And finally, I'm gonna call this post-order traversal. After I call this root node, I can return self.result. Now let's go to the difficult part. Yeah, so this is what how can we write a DP tree solution for the problem. So let's first check if there is only one node. Yeah, because this is the easiest way to solve the problem. So if there is no node, basically we don't need to, yeah, let's check. So there's at least one node. So the number of the node is at least one. So we are going to analyze if there's only one node. For example, if we only have a node 4, what we should do? So we have to check the edge cases. For this node 4, for the left side, there's no node, and for the right side, there's no node. So when the recursive function goes to the left side and the right side, what we need to return, we have to check this edge cases. So if not node, yeah, so this means even we have a node 4, but at the left side there's no node, we need to return something. So what we need to return? We need to basically return two variables because we want to calculate the number of nodes and the sum of all the subtree, the sum of all the nodes of the subtree. So basically we need to return two variables. Yeah. So if there's nothing, I'm first gonna need return a 0 and then a 0. So this means yeah, let me count. Count is the number of nodes, and another 0 is the total. Yeah, it's the total value from this node. So this means when it goes to the left side or the right side, we are sure it must be a 0. So the number of count is 0, and the total value is also 0. Now let's try to write the left side and the right side. So how should we write the left? So we can use left count, and yeah, let's say let me use left total. Yeah, let's use the left sum. It doesn't matter. Yeah, so left count and left sum should be, yeah, let's go to the left side. So we can use the post order, go to the not dot left. And similarly, we can use the recursive function, go to the right side. So the right count and right sum should go to the post order, not dot right. Yeah, up to now we are okay because there's only one node. Yeah, so for the left side, what it gonna return? It's gonna return a 0 and a 0. And for the right side, what it gonna return? It's gonna return a 0 and a 0. Yeah, because currently we are not calculating the node 4. We are calculating the left side and the right side. So this means it's gonna always return a 0. And how can we calculate the result for this node 4? Yeah, so we need to have a check. So if not.val, currently the value is 4, equal to, let's check the total sum. So the total sum would be the left sum plus the right sum, and we need also to plus this value because the left sum and the right side is both 0, but we need to plus this value. It means not dot value, and then we need to divide it and round it down to the number of nodes. And how many nodes? So it is left count. Yeah, let me put it wider enough. Left count plus the right count, and also we need to plus 1. Why? Because we need to include the root node. So from the left count it is a 0, and the right count it is a 0, and then plus this 1. So it is a 1, and the sum of them is 4. Yeah, so it means the result is 4. 4 equals to not dot value 4. It means it is one of the result. So what are we gonna do? We just need to check the result. So the self dot result should plus equal to 1. Yeah, but this is only for one node. But this is basically a recursive function. What about we have 2 nodes? Yeah, it means that we don't have this node 8. It means that we only have 4 and 5. Yeah, because for 4 and 8 it's the same. It means that we have only 2 nodes. So what are we gonna do? Of course, this is not possible. Yeah, because while we are calculating this 4, we need to get the result of the 5. It means when it goes to the 5, we need to return something. And while we are calculating this 4, we need also to return something. What we need to return? We need to return the number of the number of the code, the left code and the right code, right? Yeah. So let's return the left code plus the right code and plus 1. And we need also to return the total values. So what is the total values? It is the left sum plus the right sum plus the not dot values. Yeah. So before we do anything else, let's check if this is right. Yeah, so imagine we only have two nodes, 4 and 5. What are we gonna do? Yeah, before as I explained, if there's only one node like node 4, what are we gonna return? We just return the number of node, it is 1, and the sum is gonna be 4. But while we are checking this 5, of course we're gonna return the number of node, it should be 1, and the sum would be 5. Yeah, but while we are calculating this 4, it also gonna be the same. So the left plus the right code, and then the left sum plus the right sum, and also plus this value 4. And for the code, it should also plus 1. It means this should be right. Yeah. So while you are writing the recursive function, you need always to try to use one or two examples to prove this should be right. Yeah. Now let me run it to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it's pretty fast. It's nearly 88%, and it passed all the testing cases. Thank you for watching. If you find better ways for this solution, please make a comment. See you next time.